There are three components in the Instrumentation Hub system: the LD100 board, a Windows or Linux server application that we also provide, and the sensor boards. The topics I'm going to discuss in this video are covered in the LD100 tool user's manual. This is part of the installation package and is also available on our website. Once you get your board, the first step is to download and install the LD100 tool app. Go to instrumentationhub.com/downloads, download and save the distribution package. In this video, I will show installation on Windows OS. To install, find the distribution package file ld100_tool.rar where you saved it and unpack. Run the setup.exe from this directory and follow the instructions on your screen. The installation will generate a desktop icon for the LD100 tool application. Double-click on the application icon to launch. You can power the LD100 board over either USB or power over Ethernet. To power over Ethernet, you need a special type of network switch that provides power over the Ethernet cable. These kind of switches are widely used for IP cameras and IP telephones. You can connect to the LD100 board over either USB or Ethernet. Inexpensive Wi-Fi adapters can be connected over Ethernet for wireless networking. To establish connection between the app and the LD100, we first select the interface. LAN and LAN Plus is for Ethernet connection. With LAN Plus, the communication is encrypted. FT serial is for USB connection. There's two ways to configure the network interface. You can either enter the IP address of the LD100 board manually, or let the app discover them for you. If you go over the Keep Connection box and right-click, you will see several settings. You can set the plus-minus address range to look for the LD100 boards on the network, and also select how many boards you want to support. The LD100 scans the sensors at a settable polling interval. To set the polling interval, right-click on the sensor and enter how many times per second you want the sensor to be read. To disable all polling, right-click on J16. This brings up a context menu of the LD100 tool options. You may disable all polls here. There are 5 built-in sensor groups on the LD100 board itself. These are the GPIO, ADC, PWM, frequency counter, and serial port groups. The GPIO or General Purpose Input-Output group has 18 individually settable and readable bits. You can set an individual bit as an input or output bit. Individual bits are settable as high or low in the output mode. You can monitor whether a signal is high or low in the input mode. A typical application of a GPIO is controlling relays in the output mode and checking the state of a switch in the input mode. The PWM or Pulse Width Modulation Sensor group enables the generation of square waveforms with adjustable duty cycles and periods. Pulse modulation duty cycle is settable per pin, but the period setting is common to 5 of the PWM pins. This restriction is dictated by hardware design of the LD100 processor. J5 pin 3 is driven by a separate PWM hardware controller inside the processor, and we can set its period individually. We'll look at programming basics in this video. There will be an upcoming video that goes into the details. Instrumentation Hub system has a JSON application programming interface over TCP network protocol. JSON is a human-readable text-based encoding similar to XML. Our JSON API is based on a client-server command response model. Any programming language that has facilities for TCP can be used to write a client to access the LD100 tool server. Some languages have libraries that facilitate manipulating JSON data structures. Python has the JSON module, and C, C++ have several, for example, JSON. Let's show how to use the JSON API with Python using the Python command line. First, import the modules we need. JSON module is part of Python. We provide the sensors module. Open the connection to the LD100 tool server. We're using the one running on our local machine. We could also access a server running on a remote system. Let's ask for a sensor reading. Since we can have multiple LD100 boards on the network, we have to specify the board ID. Then we select the connector number on the LD100 board. We see the command going out and the response coming back. The response shows that this is a MAX 31856 device on SPI bus, reporting a temperature of 15.56 degrees Celsius. MQTT is a lightweight IoT messaging protocol based on the publish-subscribe model. It is supported by all cloud services. Instrumentationhub system supports the JSON API over MQTT. Let's show how we can use the JSON API over MQTT with Python using the Python command line. First, we switch the LD100 tool to work over MQTT. The JSON packets are now carried over the MQTT protocol. We're going to use two Python instances to show the operation with the Python command line. Normally, you would have the command issue and response processing in the same program. We are using the PAHO MQTT Python package for client services. We define a callback function that is invoked when a message is received. This is a simple function that prints the contents of the received message. We instantiate the MQTT client class. Then we register our callback function and connect to the MQTT server provided by the LD100 tool application. We now subscribe to the topics we're interested in. Subscribing to command and response topics enables us to see the commands issued and the responses generated. Finally, we go into a wait loop, waiting for messages on topics we have subscribed. On the other Python instance window, we instantiate the MQTT client class and connect to the MQTT server provided by the LD100 tool application. We publish a command to get the sensor reading on connector J11 of the LD100 board. Similar to the JSON API example, the response shows that this is a MAX 31856 device on SPI bus, reporting a temperature of 23.19 degrees Celsius. This concludes our small demo. Thank you for watching. Check out our website and follow us on social media for more content.